This is the experimental kit for the realization of Boolean expressions using logic gates. On the board we have 6 inputs and 6 outputs with LED indicators and a breadboard. We have NOT gates, AND gates, OR gates, NAND gates, NOR gates, XOR gates and XNOR gates. Now let us look at the manual. A detailed manual is given with each of the logic diagrams along with their truth tables. And at the end we have also provided one logic expression with the logic diagram and the minimized logic diagram, which can be implemented on the board. Let's start with the experiment. For that we will just verify the truth tables for the gates. For the NAND gate, the inputs are connected. And the output is connected here. So for the NAND gate, as we see, the truth table is for 0 0 input, output is 1, 0 1 input, output is 1, 1 0 input, output is 1, 1 1 input, output is 0. So for 0 0 input, the output is 1. For 0 1 input, the output is 1. For 1 0 input, the output is 1. For 1 1 input, the output is 0. Thus we have verified the truth table. You can do the same for all the NAND gates over here. Now let us proceed with the connection for the NOR gate. As we see the truth table, for the NOR gate is, if the inputs are 0 0, output is 1, and for all other inputs the output is 0. So when the inputs are 0 0, the output is 1. For all other combination of inputs, the output will be 0. Do the same, you can do the same for all the NOR gates. Now let us verify for the AND gate. As we see, the truth table for the AND gate shows for 0 0 input, output is 0, 0 1, output is 0, 1 0, output is 0. Only for 1 1 we get the output is 1. So for 0 0 the output is 0. For 0 1 the output still is 0. For 1 0 output is 0. For 1 1 we get the output is 1. We can verify for all the other NAND gates as well. Next, let us verify for the OR gate. Let's connect the output and the inputs. So for the OR gate truth table, for 0 0 output is 0, and for all other combinations the output will be 1. So we have 0 0 and the output here is 0. For 0 1 the output is 1. For 1 0 the output is 1. For 1 1 the output is 1. Hence we have verified the truth table for the OR gate. You can do the same for all the other OR gates. Now let us connect the NOT gate. For the NOT gate we just need one input. So for NOT gate, when the input is 0, the output will be 1. When the input is 1, the output will be 0. You can verify the same for all the NOT gates. Now let us verify the truth table for the XOR gate. Let's make the connections. So the inputs are connected and the output is also connected. If we look at the truth table, for 0 0 the output is 0. For 0 1 the output is 1. For 1 0 the output is 1, and for 1 1 the output is 0. So for 0 0 the output is 0. For 0 1 it will be 1. For 1 0 it will be 1. For 1 1 it will be 0. Hence we have verified the truth table for the OR gate, XOR gate. You can do the same for all the other XOR gates. Finally, we have the truth table for the XNOR gate. Let us do the circuit connection first. We are connecting the inputs of the XNOR gates, and now the output is connected. So the truth table shows for 0 0 the output is 1, For 0, 1, the output is 0. For 1, 0, the output is 0. For 1, 1, the output is 1. So for 0, 0, we have the output as 1. For 0, 1, the output is 0. For 1, 0, the output is 0. For 1, 1, the output is 1. Hence, we have verified the truth table for the XNOR gate. You may do the same for all the other XNOR gates. Let us now solve for one Boolean expression. According to this Boolean expression, this is the logic diagram. We will minimize the expression first, and finally this is the minimized expression we are getting, and we will try to incorporate this on the board, and we will also verify the truth table for this connection. First, we are connecting the input A to the NOT gate. So the input A is connected to one NOT gate. Next, we are connecting the input B to another NOT gate. So input B is being connected to another NOT gate. Now from the output of the NOT gate, they are going to the input of a OR gate. So these two outputs will be connected to the input of a OR gate. Okay. Now the input C is connected to a AND gate, and the output of the OR gate is also connected to the input of the same AND gate. So we will connect one input C to AND gate, and the output of the OR gate is again connected to the input of the AND gate, and the final output is the output from the AND gate. So this is our final output. Now we will verify the truth table. So for the inputs 0, 0, 0, the output should be 0. So all the inputs are 0 here, and we have the output as 0. For the input 0, 0, 1, the output will be 1. So 0, 0, 1, the output is 1. Now the input 0, 1, 0, the output is 0. So for the input 0, 1, 0, the output is 0. Now for the input 0, 1, 1, the output is 1. For the input 0, 1, 1, the output is 1. Now for the input 1, 0, 0, the output is 0. So for the input 1, 0, 0, output is 0. Next input is 1, 0, 1, the output is 1. Next input is 1, 0, 1, we have the output as 1. Next input is 1, 1, 0, output is 0. So 1, 1, 0, the output is 0. And finally we have 1, 1, 1, and the output is again 0. So we have successfully verified the truth table for a Boolean expression by minimizing it and by implementing it with the logic gates given in the board. Different Boolean expressions can be implemented using this experiment kit. This concludes our experiment. Thank you.
Please subscribe to our channel for more such videos. Thank you for watching.